Welcome to the tutorial over Lesson 1.2, Properties of Real Numbers. Let's start by doing a quick review over our Lesson 1.1. Evaluate the expression d minus f times 2 divided by c if c is 0.4, d is equal to negative 5, and f is equal to 6. First, we'll plug in d, which is negative 5, minus 6, which is f, times 2, divided by c, which is 0.4. According to the order of operations, we're going to do the parentheses first. We have negative 5 minus 6, which is negative 11, times 2 divided by 0.4. As you can see, we have multiplication here and then division. Well, multiplication and division are along the same lines. So what you'll do here is you'll just go from left to right. Okay? So first we're going to do negative 11 times 2, which is negative 22. And then we're going to divide by 0.4. And what you should get is negative 55. Now you'll try an example. Number 4. Evaluate the expression 2aw divided by z if a is negative 3, w is negative 1, and z is 1/4. First, we will plug in our numbers using parentheses. 2a is negative 3 times w, which is negative 1, divided by z, which is 1/4. Okay. First, we will evaluate the top, and then we will evaluate the denominator. Okay. So we have 2 times negative 3, which is negative 6. Negative 6 times negative 1 is positive 6. Now we have 6 divided by 1/4. When you have a number divided by a fraction, the rule is take the bottom fraction, flip it, and multiply straight across. Okay? So now we can rewrite 6 as 6 over 1 times, and if we take 1/4 and we flip it, we will then get a 4 over 1. So 6 over 1 times 4 over 1, you multiply straight across, and we get 6 times 4, which is 24. Our last quick check. One way to write the formula for the surface area of a rectangular prism is A equals 2h parentheses L plus W plus 2 times L times W. Find the surface area for the rectangular prism with length of 6 inches, width of 4 inches, and height of 2 inches. Now all we have to do is plug and chug. Make sure you've plugged in the numbers to the correct spaces. Okay. First we do parentheses, 6 plus 4, which is 10, so we have 2 times 10, plus 2 times 6 times 4. We'll do the left side first. 2 times 2 is 4, times 10 is 40. 2 times 6 is 12, times 4 is 48. So the area is equal to 88 inches squared. Now for the new stuff. Our new vocabulary will be real numbers, rational numbers, irrational numbers, integers, whole numbers, and natural numbers. Okay? These are all categories. If we look at the first category, we have rational numbers. Okay? This is denoted by a Q. Rational numbers are any decimal that terminate, meaning they end, and can be written as a fraction. Okay? Irrational numbers are numbers that go on and on and on forever. They do not end. So for instance, the square root of 3 is a number that does not end. If you look in your calculator and you plug in the square root of 3, you will see that the decimals go on. Irrationals are denoted by a capital I. The next one we have are integers. This is denoted by a capital Z. Integers are essentially numbers without decimals. So 1, 2, 3, 4, 5. They're counting numbers. Then we have whole numbers. this is like 0, 1, 2, 3. And you see that we have the square root of 36. Well, if you plug into your calculator the square root of 36, you end up getting 6, which is indeed a whole number. So any perfect square, so 1, 4, 9, 16, 25, 36, and so on and so forth, those, if you take the square root of them, they are called perfect squares. Okay, because what you get out is a whole number. So the square root of 4 is 2, square root of 9 is 3, and so on and so forth. This is denoted by a W. And the last one are natural numbers. These are the numbers that represent all numbers on a number line. Okay, so you can see that it's all of these numbers. If you take a look at this Venn diagram, a natural number is a whole number, an integer, a rational number, a real number. Okay, so it is all of those. So some of these can have more than one name. Okay, on the next slide, I'm going to put the actual definitions for you. And one thing to bring up about natural numbers is that they're the positive integers, so like 1, 2, 3, 4, 5, and so on and so forth. And we do not include the negative numbers. Do not include negatives. So here's the definitions. Real numbers are all numbers used in everyday life, the set of all rational and irrational numbers. Rational numbers are any number m divided by n, where m and n are integers and n is non-zero. The decimal form is either a terminating or a repeating decimal. An irrational number is a number that is not rational. The decimal form neither terminates nor repeats. So for instance, pi. All the decimal places are different after the decimal, and it doesn't repeat in any sort of pattern. Integers are numbers such as -3, -2, -1, 0, 1, 2, and 3, and so on. Whole numbers are the positive numbers including 0, so 0, 1, 2, 3, 4. And the natural numbers are the counting numbers 1, 2, 3, 4, etc. Let's try some examples. Example 1, name these sets of numbers to which the square root of 6 belongs. Okay, so that means that could be more than one answer. So what you want to do is you want to start with the process of elimination. We know that this is a real number, so we'll start with that. So we say real, and then in parentheses we put the capital R. And then a quick trick, what you can do, you can actually put this into your calculator, and what you should see is you get a decimal that doesn't end, and it just keeps going on and on forever, and it's not repeating the same number over and over in a pattern. Well, that falls under the irrational number category. So that's the only two categories it can be. If you take a look at your Venn diagram again, we knew that it was a real number, and we knew that it was a rational number. Well, since it was irrational, it can't be any of those. Okay, so let's try example 2, or example 1b. Name the sets of numbers to which 5 belongs. Okay, so start with real. We know that it's a real number. And then you want to ask yourself, is it rational or irrational? Well, if it can be written as a fraction, which all whole numbers can, okay, we can write it as 5/1. That means it's going to be rational as well. Then you ask yourself, is it in the nets category? Is it an integer? And in this case, yes, it is. In the last two categories, is it a whole number? Yes. And then, is it a natural number? Is it a counting number? Well, it's a counting number as well. So it's a natural number as well. So it happened to fit in every single category. Example C. Name the sets of numbers to which -2/3 belong. Okay, well, we know it's real. And then you ask yourself, is it rational or irrational? Well, it's already in the form of a fraction, so we know it's rational. And then we want to ask ourselves, okay, is it an integer? And in this case, it's not, because we can actually write this as the decimal negative 6, 6, 6, 6, 6, 6, 6, 7, and it just repeats on and on and on forever. So that indeed is not an integer because it is in fact a decimal. So it's only a real and a rational number. Now it's time for you to try to classify some numbers. Next we have some real number properties. We have the commutative property, which means that a plus b is equal to b plus a. It doesn't matter which way you write them, it's still the exact same. Same for multiplication. It doesn't matter what order that you multiply your numbers, you will still get the same answer. The associative property. If you take a plus b first and then add c, it's going to be the exact same as a plus parentheses b plus c. The same applies for multiplication. That's the associative property. The identity property. On addition, if you take a number plus 0, it's going to equal the same number. On the multiplication, the identity is multiplying by 1. So to get your identity, you have to get the same number out as you did before. Inverse, whatever you have to do to add to your number to get 0. Multiplication, you have to multiply these two numbers, and if you get 1, then it is your multiplication inverse. The closure property. You have a plus b is a real number. Okay? And then also on multiplication, a times b is a real number. And last but not least, we have the distributive property. If we have a times the quantity b plus c, that's going to be equal to a times b plus a times c. This works if you do it backwards as well. So example 2, name the property illustrated by negative 8 plus 8 plus 15 is equal to 0 plus 15. Well, if we take a look at the parentheses, we're taking 8 and its opposite and we're adding them together. Well, when you take a number plus its opposite, well, first of all, the plus means additive, and we're taking opposites, so it's the additive inverse property. Example 3. Find the additive inverse and multiplicative inverse for negative 7. First, to find the additive inverse, that means negative 7 plus some number has to make it equal 0. Well, the opposite of negative 7 is 7. So the first answer to our question is just 7. The next part, we need the multiplicative inverse. So negative 7 times some number is going to equal 1. So you can think to yourself, okay, in order to get a positive 1, I need to multiply by a negative number. Okay? Well, then we know to get the multiplicative inverse, we take 1 over our number. Okay? So our multiplicative inverse is negative 1/7. Now I would like you to try a problem. Example 4. Joel went to the grocery store and bought 3 plain chocolate candy bars for 69 cents each and 3 peanut butter candy bars for 79 cents each. How much did Joel spend altogether on candy bars? You can set this up one of two ways. You can see that you have 3 plain chocolate bars for 69 cents, and then he also spent 79 cents on 3 chocolate peanut butter. Okay, so you can take 3 times 69 plus 3 times 79. And if you can see, this is actually the same as writing 3 times 69 cents plus 79 cents because of the distributive property. I'm not going to give you the answer. You go ahead and do it yourself. Example 5. Simplify an expression. What we have to do first is the distributive property to both of these expressions. We get 4 times 3a, which gives you 12a. And then we have 4 times negative b, which is negative 4b. Plus, for the next one, we have 2 times b. And always, always, always put parentheses on your second expression. Because if this was a negative, it would end up changing all of your signs. Okay, so we have 2 times 3a, so 2 times 3 is 6, so plus 6a. And in this case, since it's just a positive sign, we can actually drop our parentheses. Okay. And the last steps is to combine like terms. So we have 12a plus 6a and negative 4b plus 2b. That will give us an answer of 18a minus 2b. Now I would like you to try an example. Thank you for watching the tutorial on 1.2. See you in the next video.